All right, y'all, so we're measuring piston deck height here. And so what we're looking at is how far the piston is either in the hole, meaning below the deck surface, or how much it pops out of the hole, which means it's above the deck surface. I don't know if you can see real good right there. It's actually in the hole just a little bit. So what I've done is I found true top dead center. Got my magnetic base dial indicator right here. We got it at 0. If I rotate the crankshaft, you can see the piston goes down, come up, top dead center, goes back down. So we get it trued right at top dead center. So right, back up a little bit. Right there. Okay, so we got it, and I got it 0. So now all I'm going to do is, since it's a magnetic base dial indicator, I can take it and we got it on a nice clean flat surface, the block, the deck of the block, and so I'm going to take it and put it on the flat surface, and that should tell us how many thousandths of an inch our pistons are in the hole. So bear with me for a second. I'm going to have to set this down for just 1 second. I know that's very unprofessional. I'm going to have to figure out some type of editing equipment. Anyway, so all right, so you see I got it sitting on the deck. I had it zeroed when it was on the piston. And as you can see, we are now 15 thousandths of an inch difference. The reason why that's important, piston to cylinder head clearance. If you run less than, oh man, okay, so it really depends on the rod, the RPM, the type of piston. But typically you want to keep it above like 32 thousandths to be safe. I've personally run engines all the way down to about 27 thousandths and had good luck with that. You don't want to run much looser than about 60 thousandths because there's a lot of benefits of having a tight piston to cylinder head area. It's what they call quench. Quench is, well, I can show you a good little, all right, so you see this flat area of the piston right here? That's your quench pad. What happens is, as the piston comes up and gets really close to that flat area, all the air and fuel that's in that flat area gets shoved into the combustion chamber and gets swirled up real fast. That creates a lot of turbulence in the mixture, mixes it up real well, gets better flame propagation because it has a more consistent air-fuel mixture across the combustion chamber, gets you a little further out of detonation, allows you to run more compression ratio or more boost, depending on your application, or more nitrous, and still stay in a safe area, safe zone. So on this engine, I've got 15 thousandths. I'm probably going to get a 20 thousandths shim head gasket, which that'll give me right at 35 thousandths piston to cylinder head clearance, which I'll be happy with that. I could probably go a little bit tighter, but really don't need to. I'm already at the compression ratio that I desire, and everything should be happy. And watch, I can do this to show you that it's still zeroed. Move it back on the piston and it goes back to 0. You want to check your piston deck height parallel with your wrist pin, because so the wrist pin runs this way across the piston. If you don't, you have piston rock. The piston can actually rock back and forth this way. With the wrist pin, it can't rotate, it can't rock this way. So your true reading is going to be across the center of the piston in line with the wrist pin. Now, to show you what I'm talking about as far as that quench area, let me shuffle things around here for a second. Okay, so this is our combustion chamber right here. That flat spot on the piston is going to coincide with this flat spot on the cylinder head. So when that flat spot gets close, it thrusts everything into the combustion chamber, and it makes everything happier. When you start getting beyond 60 thousandths of quench, you lose that effect. So that's why we look to get a fairly tight piston to cylinder head quench. And that's all for now.